What's up, guys? Welcome to the Hawk Crypto Mining YouTube channel. Today I am joined by a very special guest and a good friend of mine, Mr. Yeti. Yeti, what's going on, man? How are you?
Yeah, doing good, man. It's been a while since we had this another chat, right?
Yeah, it's been a minute, man. It's been a minute. I'm really excited, man, because I heard you got involved with Dynex and it's only getting deeper. So talk to me, bro. Like, update me. And it's been a while. How did you get involved with Dynex? Like, what are you doing? Like, give me the skinny.
Yeah, so I mean, for the last 6 to 8 months, I've been helping around with Dynex,
right?
Been doing a lot of their security stuff and audits and giving them suggestions and helping out where I can. And then obviously in January, I flew out to America and did Fox News for Dynex. Really, from then it was a case that they realized that pretty much that it was time to make this arrangement a bit more formal.
Right.
So they decided to offer me basically a contract I couldn't refuse.
Right.
So at that point I was like, well, okay, we checked checked through the responsibilities, made sure that was okay, but they offered me the position of head of ecosystem and information security. So I still do pretty much what I was already doing.
Right.
Just now I'm more official.
It's official now. So, yeah. So when you started with Dynex, what was one of the first things that they asked you for help on, and how did it evolve into where you're going now?
That's a really good one. So right at the very beginning, that was me and Chump Change doing a wallet audit. It was one of the first wallet audits we ever did, with the idea in mind to put the data out there every audit that we were going to do.
Right.
And I reached out to Dynex and said, look, this is what I'm doing. They were very helpful. They were more than happy to allow me to sit there and pick through their code and give them suggestions and recommendations. And from there, it really just grew. I sort of said to them, look, I'd really love to help with the security aspects when you start doing your machine learning jobs, and see if I could lend my assistance. Right, my background as a security consultant in the IT space obviously helped a huge amount. Right. And yeah, from then it's just snowballed one thing after another, and till now I'm running the ecosystem, and yeah, I'm responsible for like 20 staff, something like that.
Jeez, I could just imagine.
Crazy.
I could just imagine, hey, Yeti, hey, do you know anything about this? Can you help us with this? And then it kind of goes into that role, and then it kind of like snowballs forward, right? That's interesting, man. And, we worked together in the past. We've been friends for a while, and it's amazing to see like kind of how everything changes in a year. You know what I mean? Like a year ago, it was a little different, and people were doing different things. You were doing different things. We had just started Terra. You actually helped us out at Terra in the beginning, and things are just going crazy. I never would have expected it to grow this fast and you to be where you're at with Dynex, man. So it's crazy. You
with Terra and all the lads, at Terra, you're doing fantastic. I'm now obviously in a blockchain company, which wasn't my original plan at all. Right. I was just offering some advice and some help, and it just blossomed from there, sort of thing. So it's good that we're both doing okay, but what it's meant is that I haven't really spoke to you properly about things in months.
Yeah, it's been busy. It's been busy, and I had my son, and just things are just we're crazy at the time. So, but Yeti, I want to get into this really important question here: is where do you think Dynex is headed, and what are some of the most recent accomplishments that Dynex has made to date?
Sure. I mean, that's a very valid question, right? Most people want to know what we're doing or how we're doing it, and then what they want to know is real world applications, right? That for us is something that we're priding ourselves with, right? We're the first neuromorphic network on chain that is solving real world problems. So
real quick, Yeti, for the people that are watching and they don't understand the word neuromorphic, give me like the Spark Notes version of what neuromorphic is.
Yeah. So we built our system with a biological approach to it. So it mimics the same way that a human brain works in a lot of the ways. So it can do parallel job processing, for example. That's something that we do as humans, completely autonomously, right? You pick up a drink, right? You don't stop breathing when you're drinking.
No.
That's an automatic function, right? It's just something that's part of the brain. And it's the same for Dynex. We can run 2, 3, 4,000 jobs all at the same second because the neuromorphic network's so flexible in that way that it's got so rampant efficiency. Like, it's lightning quick. So jobs that you would expect take hours take minutes. Well, it means that those jobs are off the network before it's even got congested.
Right.
So from an expansion phase that we're sort of working through right now, like, for what Dynex plans to do in the future is we're going to keep pushing the boundaries. We want more capability, shall we say, right?
Right.
The more flexible we make our system, the more appealing we are to other customers that may not want to use us because they think, oh, well, they're talking about quantum, they're talking about neuromorphic, and all of a sudden, right, there's a big problem.
Right.
We're trying to shorten the term to like an N quantum.
Right.
But even that still doesn't quite get everyone to understand what it is. So, but in a nutshell, a neuromorphic network is just like a huge brain at that point.
While supporting the GPU mining community as well, and using the compute, I believe, from the GPU miners, to support this network, which is awesome. Now, I did see Dynex had a marketplace. Real briefly, how is that performing? Are you guys getting a lot of clients on there? Is it expanding? It is.
It is really well. So if I just pull up the exact stats of that. So I believe, so in the last few months, it's been averaging around anywhere between 30 and sort of 50 grand a month inbound. And obviously that's distributed to the miners. There's a large portion of it. 70% goes to the miners. 20% obviously goes to Dynex development. And that includes their Moonshot Foundation, which is for startup projects that wish to use Dynex and don't have the funding yet.
Right.
We have now a facility called Dynex Moonshots for that purpose. And then we've also got we've now got the Dynex Holders Incentive Program, which most people believe is staking. It's anywhere far from staking. So all you have to do is have it in your wallet. You don't have to stake it. You don't have to lock it up. You don't have to do anything. In the wallet, there is a little button that says proof of balance.
Okay.
And all you do is you take the file upload that it gives you, and you put it into the portal in the Dynex Holders Incentive Program portal. And then that registers you, and every month you get your percentage based on your holdings of a 10% slice of the profits from the marketplace.
10%.
So we gave out 5 grand this month.
That's very interesting. So it's not staking, but you get benefits for holding your Dynex in your wallet and by entering the information into the portal. That's actually really interesting. Really interesting. Yeah. Okay, Yeti, so I see you got the marketplace up here. This looks really good. So how does this work?
So pretty much once you've logged in, there is 3 steps to get running on Dynex. 1, register the account and download your API key. Right. Step 2, to basically download our SDK. It's available in Python. It's if you use PIP, you can do PIP install Dynex, and it will download the Dynex packages for you. That's all of the different packages we use, and therefore, no matter which way you want to, do your work, you'll be able to just tie into the package that you need to use. Right. And then third off is just a very small snippet that allows you to test run to make sure that all your account is active, it's working, and everything like that. It really is that simple.
I really like the design here. Like, this was done really well. Now, Yeti, I don't mean to jump forward, but you said you were going to show me some work that was being done. I got to see this. What do you got to show me? Because I think the viewers really want to know the capability of what Dynex is doing.
Okay, benchmark or results? Which would you prefer first?
Well, let's go to benchmark, and then I guess we could see the results afterward. Is that usually how it goes?
So what you're seeing here is the our pretty much fresh today Dynex benchmarks.
Wow.
So this is traditional CFD using a H100 GPU, which on Dynex, if you actually put a H100 to mine Dynex, would actually equate to the same number of chips that we used to do the benchmark. So it's 1,000 chips.
Wow.
So we're actually able to give it a proper apples to apples comparison at that point. And you can see here that, so what's really funny is that as you scale obviously the job up on a traditional, it's just going to keep going up and up and up and up. That's time and obviously money, because if you're renting that GPU, for example, you're paying by the hour, right? You've done vast, you understand this, right?
Mm-hmm.
You end up renting by the hour, and therefore it gets very expensive very fast.
Yes, it can. It adds up. They use, they factor in the bandwidth, the storage and all that stuff, right?
Yeah. And what we found once we started doing our test runs, right? So the orange line on that screen is traditional.
Okay.
The blue line, and you might not be able to see it, it's all the way down at the bottom.
You can see it.
It's all the way back down here, basically. It's just a flat line, no matter which size of the job we do. Because as we flex the need for more resources, it just brings on more resources. And therefore it finishes almost, well, when we did our test runs, it literally finished within a 1 degree variant of each other.
So it doesn't increase time the heavier the load?
Not really, not in a quantum state, because you're doing all of those variables all at the same time.
Wow, that's impressive.
Obviously a traditional CPU does one calculation, one return.
Right.
One calculation, one return. I mean, this happens milliseconds, like we're talking split second here.
Right.
And it does a lot of them. But quantum based algorithms allow you to just go, oh, I need to send 10 million variables all at the same time.
Right.
And it will just start calculating. So what we found is that compared to me using and renting a H100,
mm-hmm.
compared to run it on Dynex was 95% cheaper, and 95% faster, 90% cheaper than the traditional.
Yeah, I see it on the cost comparison here that the cost doesn't go up at all for the increased load or amount of data points. So that's pretty interesting. It's pretty interesting how that works.
It's something that we weren't even actually anticipating would happen. We actually thought at some point we'd hit a point where you would see it start rise up, right? Because obviously the more data you're giving it, the more time it's going to take, the more processing it needs.
Right.
But actually, CFD on Dynex seems to just be a match made in heaven.
Right.
It really is. It's just so optimal for Dynex to run CFD.
Right. And for my viewers out there, Yeti, what does CFD mean?
So CFD stands for computational fluid dynamics.
Okay.
And what that basically means is take an object and now you can push air at it and you can figure out what the air can do, or you could push a liquid at it and figure out what the liquid can do.
So you have traditional CFD, you have quantum CFD, and this is how you're comparing the amount of compute that it can do. Right.
OpenFOAM is a program that's free and open source, but it's a CFD program.
Right.
And what you can do is you load in your model, you give it a GPU, you can hit go, and it'll do it all locally, but it'll take ages. Right. It's not designed for that kind of purpose. You've got to have really high-end GPUs at that point. But Dynex opens the door for your everyday person. If they wanted to get into CFD and didn't know and didn't want to spend an absorbent amount of money being able to test their theories and their code, Dynex is right there now and an option. And like I say, it's been a bit of a fascinating project doing the benchmarking, because there's traits there that we just didn't even know at the time. It's still a learning process, right? This is so new technology. We just don't know where it peaks out.
Right.
We don't know where it stops. There's still so many unknowns for us until we really scale it up. Now, we've got the capability of scaling up past 10,000 jobs
a
second, probably. but we won't know what happens until we actually reach that point, right? So we've only been open since officially to customers since the 13th of December.
Well, I can tell you this: if anybody can push it to the limit, it's you. So definitely, I know, because I've watched you over the years now. You know, do just from like a crypto mining perspective, just pushing cards and pushing algorithms and miners to their limit. So
yeah,
it's interesting. Yeti, show me the render now. Explain this to me. This is exciting. I want to see this. So this is a render of an F-16.
Yes. So this is an F-16 in our virtual wind tunnel environment.
Okay.
And then if I press play, you'll see how it renders in Dynex.
Okay, so so you're looking at the aerodynamics.
So you can see how the aero is affected by all the objects. And as you can see there, where the ram scoop is at the bottom, you see it go red?
Yeah.
Because obviously the ram scoop idea on an F-16 is to squeeze that air to actually make it thinner profile as it's punching through the air.
Right.
So it's really cool that corroborates what we know actually about the plane, right? And its mechanics, that the actual CFD is exactly showing what we would expect. What we found was we're at like 99.8% accuracy. Obviously, the more you push at it, you have to refine the code down to get the accuracy. But obviously, if you've already got something that's pre-built that's already accurate, then plugging it into Dynex should meet your criteria straight away.
Yeah, and it's funny because when I was a kid, I always wanted to be a fighter pilot, and I studied planes a lot. And the F-16, the F-22 were some of my favorite planes growing up. The F-18 Hornet and all that stuff. Yeti, this is actually really, really cool that Dynex can get really close to within the accuracy of what the engineers built the plane to be, just using the neuromorphic compute. Man, that's impressive.
It's
really
an incredible journey that the CFD has put us on, right? Because we thought that it would be a really good product for us. We didn't quite realize just how good it could run on our system until we really did stress it out with a full run. Like, as you can see there, that's 15 seconds of CFD. Now, bear in mind that every second you add is compounded.
Right.
So it's to the factor of, because every time you do an iteration, it has to remember everything before.
Correct.
And that's where obviously quantum computing really does come into its own, because you can do all of those jobs simultaneously, and one waits for the next, which waits for the next, which waits for the next, and before you know it, it's effectively done them all.
Yeti, a lot of people, and I'm just being honest here, a lot of people will criticize and say, how can you do quantum computing while using traditional hardware? Aren't quantum computers, completely different from a hardware perspective? What's your answer? Because I know you get this a lot. What's your answer to some of these critics?
Actually, they're partially right. So the way that we do our quantum annealing and quantum circuits is by using our Dynex chips, right? And that is a simulated circuit on ordinary existing technology.
Right.
Basically, the neuromorphic chip is a 4-part chip, and the one bit that's been a bit of a struggle for the actual hardware to be built and exist, and they do exist, but they just wear out too fast. It's called a memsistor, not a resistor, a memsistor.
Okay.
Right. And what that does is it helps with quantum superpositioning.
Right.
So if you take a figure of 8, right in the middle of where both pass over is 0.
Right.
And that's your superposition.
Right.
And it always wants to find that superposition state.
Right.
But a memsistor wears out, and what happens is this figure 8 starts getting bigger, and then it starts getting deviated, and then all your results are skewed.
Okay.
Well, the benefit of Dynex is there's no physical hardware, it's being simulated.
Right.
And what it allows us to do is simulate a memsistor, which the technology is all out there. There's plenty of white papers, and this is all in our white paper as well. The memsistor and simulating quantum annealing is a valid piece of research. It's been out for nearly 10 years. It's just nobody's ever thought about doing it on this type of system at this scale.
Right.
We're very much trying to pioneer that research into that.
Right.
So
That's I got to tell you, man, that is really impressive. So Yeti, these are all the GPUs now on the Dynex network. What exactly am I looking at here?
So it's basically a pure overview of our network. It breaks down all the different card manufacturers, all the different models. So as you can see right now, the topmost card on our network right now is a CMP 30HX card.
Really?
Which is quite a surprise, actually. I would have assumed, but then if you look at the numbers, it is very close with, you know, your 1660s, your P106s. The 3070 was the one that was pretty cool to see right up there as well, because a lot of us have gone and purchased 3070s over the months, right?
I'm kind of curious as to why the CMP 30HX would be over the 50HX. How does it? What,
No. So that the position it's at is based on the number of cards actually on our network.
Oh, okay.
So
I'm sorry.
15,736 currently CMP 30HX cards.
Oh,
I didn't even
that's
realize
what
they
the
made
number
that
is.
many cards.
Okay,
I didn't
I'm
even
sorry.
realize they made that many cards.
I'm sorry. So you have a total of 30 CMP, a total of 15,000 CMP 30HXs. I'm sorry, that's my misunderstanding.
No, it's fine. And then obviously, so for example, there's 14,000 3070s on the network right now. It's a lot of 3070s.
Wow. Yeah, that's a lot of 3070s.
But what this also gave us was a rough, so we've got a rough price bracket of what RRP, or I'm not quite sure how Ivan set it up, our platform guy, but you can see there a price that's attached to it, right? So for example, a 3070 is saying 250. I would say that's probably there or thereabouts ish.
Yeah, for the price of the GPU, that's about it's close. Yeah, it's within the ballpark.
So what it does is it calculates how much, if you were to go and buy this right now, everything that's on our network, so 128,451 GPUs, this would be the price you would be paying.
Yeah, over $25 million.
$25 million.
I'm looking at your petaflops. I'm sorry, I want to move over just a little bit. 28.49 petaflops. Now, explain to me petaflops in compute.
Sure.
Which float is it? Sure. I don't know much about it. So how does it work?
We use FP64 double precision float.
Okay.
Might go over people's heads, but needless to say, what it does mean is our petaflops are ridiculously high given the number of units we got online.
Right.
And this is barely scratching the surface, because remember back in July when we were all mining Dynex, right?
Yep.
We had 3 times the amount of GPUs on the network. So it would have been roughly 3 times as much petaflops on the network at that time.
Right.
What's really crazy is that number there puts us number 23 on the top 500 supercomputers in the world.
Wow. So you're in the top 25.
Yeah.
Already. Now what's the top 5? Where do they at as far as
so the top 5, actually I've got them here. Hang on one second. I will actually pull them up. So this is when we took the picture, which was at 30.18, right? So it's a little bit lower than it was the last time we checked, but you can see there we're number 23. Frontier is the largest by considerable margin. I believe that's owned by Google.
Right.
I'm pretty sure it's
that's
Google.
impressive, man. You get the top 25 supercomputers
no, it's
in the world.
Packard.
Oh, Hewlett Packard owns that?
Yeah.
I mean, it's impressive, man. It's impressive.
Yeah. I mean, Frontier is the size of a data center, though.
Right. Well, yeah, of course.
It's an entire building just full of GPUs and CPUs.
Right.
Whereas, obviously, Dynex doesn't have that overhead. That's
Right.
the mad thing about it, right? We have a blockchain. We can harness all of that raw compute and equate it to the same level as massive supercomputers that take up buildings and rooms in buildings and so forth. So it's really cool.
That is very, very cool, man. Honestly,
Yes,
I am so impressed about what Dynex is doing. Now, Yeti, real quick, we'll touch a little bit on this. What exactly makes Dynex so different from other projects that are claiming to be proof of useful work?
Okay, so I'll use the short term, but POUW. So our POUW mechanism and our POW mechanism, the proof of work module side of it,
Right.
we have an entwined network, right? So one won't work without the other, basically.
Correct.
Eventually, those two will become one, and you won't actually see the two individual sides of the entanglement. It'll just be one to the system.
Correct.
But fundamentally, we are only wanting to focus on computation problems. Right. We're not planning on building out decentralized storage. We're not building out decentralized infrastructure in that respect, right? We are doing decentralized infrastructure because that's what effectively a supercomputer is, but we're one end of the scale. Effectively, we're just doing supercomputing. Then you've obviously got places like, Alephium's got their proof of less work, although it's not quite the same as proof of useful work, but it's close enough for this example. They're doing it as a very different option, right? As more workload goes on the network, they've got a sliding scale that reduces the rewards and so forth like that. So then you've got somebody like Flux, who does full decentralized infrastructure, right? That's storage, websites, basically trying to take most of Web 2 to a Web 3 platform. And that's fine. There's enough room for all of us, basically. Like, you've got Render, who just solely deal with rendering. You've got Okta, which does decentralized VPNs, and now rendering as well for videos and images. So there's enough room in the space for everyone to coexist, I would say. But we're very much up the other end of the scale compared to a lot of them, because a lot of them are doing like AI model training for like ChatGPT, image quality and rendering out from basically nothing but a sentence, an image, or a video.
Question for you.
Sora was the recent one from Microsoft, right?
I have a question, actually. Could Dynex be used to process ChatGPT, for example?
So you're talking about large language models, right? Or LLMs, So we announced this at our roadmap the other week. We are investigating trying to build the very first quantum-based LLM.
Really?
Now, there's nothing, because inherently it doesn't really lend itself very well to LLMs. However, we have a very smart guy by the name of Adam, right? He's got to have at least a 160, 170 IQ, that man. Like, he could go and work anywhere. He chooses to work at Dynex because he believes in the project. But his understanding of what we can push the system to is just on another next level of ideas. And he's actually come up with a concept. Now, that's what the R&D part was as part of the roadmap. That's what we're planning on doing. If it turns out and it works, then we're going to activate it and we're going to start trialing large language models on quantum-based algorithms.
That could be a complete game changer to like everything that's out right now. I mean, when you talk about, so here's my thing. There have been a few companies that are trying to build an actual quantum computer. Now, this may be like a really far-fetched question, but would Dynex ever consider in the future to try to actually build like a quantum computer or something close? Because I can tell you this, I've watched some of these documentaries, and these people are saying that these computers, they have to be like ultra cold, and they use like tons of power. Like I'm sure your gears were turning on this already, but what's your thoughts on that?
So actual physical hardware, right? We have considered. We've talked about it. Me and Sumi have definitely talked about this a number of times. The inherent problem comes with the fact that the MEMS there isn't the technology to stop it from degrading yet. Now, if there was, maybe we would look into maybe building a specific Dynex card, for example, right? We could work with a GPU manufacturer, write a custom BIOS to be able to interact with it. Fantastic. Until that day really happens, we can't at the moment, because it it won't match our requirements. Our requirements are quite strict in what we expect our system to be able to do.
Right.
Right. Our customers who are going to use it have obviously got an expectation as well. So
Right.
from that, we're leaning probably that we won't build anything just yet. But if suddenly there was a breakthrough, believe you me, I'd be on the phone to them immediately asking for a meeting to go and speak to them about it.
Maybe just like a small form factor, you know, that could obviously be scalable.
Yep.
You know, that would maybe be pretty interesting.
Yeah, you're not wrong. You're not wrong. I mean, if I could find somebody that would build it and it would be reliable, I'd be all over that in a million years. Like, I'd be wanting to test it. I'd be wanting to trial it. I'd go and call the company. I'd go and visit personally if I needed to make that happen.
Right. All right, Yeti. Well, I really appreciate you coming on the channel today, man. What are some last minute thoughts before we sign off on Dynex? Let me know.
Sure. I mean, so we're actually planning on doing regular dev calls per month going forward.
Nice.
Myself and Ivan are going to do the first one just because the first one's probably going to be a bit bumpy.
Right.
I'm also hosting it, so it's going to be bumpy for me too. But literally, there's so much to look forward to coming over the next 6 to 12 months with Dynex. We're also starting to attend shows.
Right.
So first one is literally in 6 days' time. I'm flying out to Dubai for Token 2049.
That's awesome.
So you know we're going quite heavy on the staff over to Dubai. So if you're in Token 2049, look out for the t-shirts. We'll all be wearing Dynex t-shirts. Yep. There'll be also a special guest appearing with a special message on the back. Let's say it starts with S.
I have no idea. I can't think. It's going right over.
And who everyone wants to meet.
Oh, Sumi. He's gonna be there.
I said nothing.
I didn't. I just took a guess, man. Well, guys, make sure you follow up with Yeti and find out if Sumi's actually really gonna be there. I really appreciate it, Yeti, guys. Comment, like, subscribe, hit that notification bell. I'll see you on the next one. Yeti, thank you so much, man. Go to sleep. I know it's late over there. Thank you.
Yep, no worries, buddy.
Take care.